The cable mentioned, BS600 Volt IMSA 20-1, is indeed suitable for wet locations. NEC Section 300.5 states that conductors installed in wet locations shall be of a type approved for use in wet locations. NEC Table 310.13 lists Type IM cable as being approved for use in wet locations. Looking at the BS600 Volt IMSA 20-1 cable characteristics, it's an insulated metal sheath cable rated for 600 volts, approved for use in wet locations, and resistant to moisture and abrasion. IMSA cables are designed with a moisture-resistant outer sheath and insulation that protects the conductors from moisture ingress. They are commonly used in underground applications where they may be exposed to water or other moisture sources. The NEC requires that cables used in wet locations be approved for such use to ensure safety and functionality. In conclusion, based on this information, the BS600 Volt IMSA 20-1 cable is suitable for use in a wet location where the electrical meter was installed. It meets the requirements of the NEC and is designed to provide reliable performance in harsh conditions. Considering the NEC requirements for conductors in wet locations, it is essential to understand why specific cables like IMSA are suitable for such environments. Firstly, let's elaborate on NEC Section 300.5. This section isn't just a general statement, it's a fundamental requirement for electrical safety. Wet locations pose a significant risk of electrical shock and corrosion. Therefore, any conductor used in such an environment must be specifically designed and approved to withstand these conditions. The approval process typically involves rigorous testing to ensure the cable's insulation and overall construction prevent moisture ingress and maintain their electrical properties when exposed to water. Secondly, NEC Table 310.13 provides a comprehensive list of cable types and their allowable applications. The inclusion of Type IM cable on this list signifies that it has met the NEC stringent requirements for wet location use. This table is a critical resource for electrical professionals to ensure they are selecting the appropriate cable for a given application. Now, let's delve deeper into the characteristics of BS600 Volt IMSA 20-1 cable that make it suitable for wet locations. The insulated metal sheath, or IMS, construction is a key factor. The metal sheath provides a physical barrier against moisture, preventing it from reaching the conductors. The 600 volt rating indicates the cable's ability to safely handle that voltage level in its intended application. The approval for wet locations means the cable has been specifically tested and certified to perform reliably in damp or submerged environments. The resistance to moisture and abrasion is essential for underground applications where the cable is exposed to both water and physical stress from the surrounding soil and rocks. The moisture-resistant outer sheath and insulation play a crucial role in protecting the conductors from moisture ingress. These materials are typically made of specialized polymers that repel water and maintain their insulating properties even when wet. The design considerations for IMSA cables go beyond just the materials used. The manufacturing process also includes steps to ensure a tight seal around the conductors and prevent any gaps where moisture could penetrate. The cable is often subjected to pressure testing to verify its water tightness. Underground applications present unique challenges for electrical cables. In addition to moisture, cables may be exposed to corrosive chemicals in the soil, temperature fluctuations, and physical damage from digging or other activities. IMSA cables are designed to withstand these harsh conditions, ensuring a long service life and reliable performance. The NEC requirements for cables in wet locations are not arbitrary. They are based on years of experience and research into the causes of electrical failures. Using the correct cable type in a wet location is essential for preventing electrical shocks, fires, and equipment damage. Failing to do so can have serious consequences. When installing IMSA cable in wet locations, it is important to follow the manufacturer's instructions and the NEC guidelines. This includes ensuring proper sealing of connections and protecting the cable from physical damage. Regular inspections should be conducted to check for any signs of deterioration or damage. In summary, the BS600 Volt IMSA 20-1 cable is a suitable choice for wet locations due to its IMS construction, moisture-resistant materials, and compliance with NEC requirements. Using this type of cable helps ensure electrical safety and reliable performance in demanding environments. Furthermore, understanding the specific properties and design features of IMSA cable will allow for a better and deeper understanding of why it is suited to perform in harsh environments. Firstly, the composition of the IMSA cable is constructed to create a reliable barrier against moisture. The metal sheath acts not only as a physical protector but also as a shield against electromagnetic interference, ensuring signal integrity, especially crucial in traffic signal applications. The specific alloy used in the sheath is selected for its corrosion resistance, often an aluminum alloy or stainless steel, depending on the soil conditions where it is installed. Secondly, the insulation material surrounding the conductors is equally important. Cross-linked polyethylene, or XLPE, is commonly used due to its excellent electrical properties, thermal stability, and resistance to moisture. This material maintains its dielectric strength even when exposed to prolonged wet conditions, preventing current leakage and short circuits. The manufacturing process involves extruding the XLPE around the conductors and then cross-linking it through chemical or radiation processes. This cross-linking creates a three-dimensional network that enhances its mechanical and thermal properties, making it more durable and resistant to degradation. Thirdly, the IMSA 20-1 specification indicates specific standards related to the cable's construction and performance. The 20-1 designation refers to the Institute of Municipal Signal Association standard, ensuring that the cable meets certain benchmarks for traffic signal applications. This includes requirements for conductor size, insulation thickness, and overall cable diameter. These standards ensure interoperability and reliability in traffic signal systems. In addition to the materials and construction, the installation practices also play a crucial role in maintaining the cable's integrity in wet locations. Proper sealing of cable terminations is essential to prevent moisture from entering the cable core. Heat shrink tubing or epoxy-filled connectors are often used to create a watertight seal. A cable should also be installed in a manner that minimizes mechanical stress and abrasion. This may involve using conduit or other protective measures to shield the cable from physical damage. Regular inspections and maintenance are necessary to ensure the long-term reliability of the cable. This includes checking for any signs of corrosion, abrasion, or water ingress. Any damaged sections should be repaired or replaced promptly to prevent further deterioration. The NEC guidelines provide specific requirements for installing cables in wet locations. These guidelines address issues such as burial depth, conduit requirements, and bonding and grounding. Adhering to these guidelines is crucial for ensuring electrical safety and preventing equipment damage. In addition to IMSA cable, other types of cables are also suitable for wet locations, depending on the specific application. These include THWN, XHHW, and UF cables. Each of these cable types has its own specific properties and limitations, so it is important to select the appropriate cable for the intended use. In conclusion, the BS600 Volt IMSA 20-1 cable is well suited for wet locations due to its robust construction, moisture-resistant materials, and compliance with industry standards. Understanding the specific properties and design features of this cable, as well as proper installation and maintenance practices, is essential for ensuring electrical safety and reliable performance. Furthermore, the suitability of IMSA cable for wet locations goes beyond just meeting the basic requirements of the NEC. The cable is designed to withstand the specific challenges posed by underground environments, ensuring a long and reliable service life. Firstly, the cable's ability to resist chemical corrosion is critical in underground applications. Soil can contain a variety of corrosive chemicals such as chlorides, sulfates, and acids, which can attack the metal sheath and insulation of the cable. IMSA cables are typically made with corrosion-resistant materials or have a protective coating to prevent chemical attack. Secondly, the cable's ability to withstand physical stress is also important. Underground cables can be subjected to mechanical stress from soil movement, digging, and other activities. IMSA cables are designed to be flexible and durable, allowing them to withstand these stresses without damage. Thirdly, the cable's ability to maintain its electrical properties over time is essential. Underground cables can be exposed to temperature fluctuations, moisture, and other environmental factors that can degrade the insulation and conductors. IMSA cables are made with high-quality materials that are designed to maintain their electrical properties over the long term. In addition to these specific design features, installation practices also play a crucial role in ensuring the cable's long-term performance. Proper burial depth is essential to protect the cable from physical damage and temperature fluctuations. The NEC specifies minimum burial depths for different types of cables and applications. Proper backfilling is also important to prevent soil movement and stress on the cable. The backfill material should be free of sharp objects and should be compacted properly to provide support for the cable. Proper grounding and bonding are essential for electrical safety. The grounding system should be designed to protect against electrical shocks and to provide a path for fault current to flow back to the source. The bonding system should be designed to minimize voltage differences between different metal parts of the electrical system. Regular inspections and maintenance are necessary to ensure the long-term reliability of the cable. This includes checking for any signs of corrosion, abrasion, or water ingress. Any damaged section should be repaired or replaced promptly to prevent further deterioration. In addition to the technical aspects, it's also important to consider the economic factors when selecting a cable for a wet location. While IMSA cable may be more expensive than other types of cables, its long-term reliability and durability can offset the higher initial cost. Choosing the right cable for the application can prevent costly repairs and downtime in the future. In conclusion, the BS600 Volt IMSA 20-1 cable is an excellent choice for wet locations due to its robust design, resistance to chemical corrosion and physical stress, and long-term reliability. Proper installation and maintenance practices are essential for ensuring the cable's long-term performance and electrical safety. By following these guidelines, electrical professionals can ensure that underground electrical systems operate safely and reliably for many years to come. Furthermore, the selection of IMSA cable for traffic signal applications in wet locations also considers the specific requirements of these systems. Firstly, traffic signals often require cables with multiple conductors to control the various lights and signals. IMSA 20-1 cable is available with different numbers of conductors to meet these needs. The conductors are typically color-coded to facilitate wiring and troubleshooting. Secondly, traffic signals often operate in harsh environments with extreme temperatures and exposure to sunlight. IMSA cable is designed to withstand these conditions without degradation. The cable's insulation is typically UV resistant to prevent cracking and fading from prolonged exposure to sunlight. Thirdly, traffic signals must be reliable to ensure the safe and efficient flow of traffic. IMSA cable is designed to provide a reliable connection for many years with minimal maintenance. The cable's robust construction and high-quality materials help to prevent failures and downtime. In addition to these specific requirements, traffic signal cables must also comply with local regulations and standards. These regulations may specify requirements for cable type, installation practices, and testing procedures. Electrical professionals must be familiar with these regulations to ensure compliance. When installing IMSA cable for traffic signals, it is important to follow the manufacturer's instructions and the local regulations. This includes ensuring proper sealing of connections, protecting the cable from physical damage, and verifying the continuity and insulation resistance of the conductors. Regular inspections should be conducted to check for any signs of deterioration or damage. Any damaged sections should be repaired or replaced promptly to prevent further deterioration. In addition to IMSA cable, other types of cables may be used for traffic signals, depending on the specific application. These include direct burial cable, conduit cable, and aerial cable. Each of these cable types has its own specific properties and limitations, so it is important to select the appropriate cable for the intended use. In conclusion, the BS600 Volt IMSA 20-1 cable is a suitable choice for traffic signal applications in wet locations due to its robust construction, resistance to harsh environments, and compliance with industry standards. Proper installation and maintenance practices are essential for ensuring the cable's long-term performance and the safe and efficient operation of traffic signals. Additionally, the durability and reliability of IMSA cable in wet environments are enhanced by several key factors. Firstly, the manufacturing process includes rigorous quality control measures to ensure that the cable meets the required specifications. This includes testing the cable for tensile strength, elongation, and insulation resistance. Secondly, the cable's design incorporates features to prevent water from wicking into the conductors. This may include the use of water-blocking compounds or tapes that swell when exposed to moisture, creating a seal that prevents further water ingress. Thirdly, the cable's metal sheath provides a path for fault current to flow back to the source in the event of a short circuit. This helps to protect against electrical shock and to prevent equipment damage. In addition to these design features, the installation practices also play a crucial role in maintaining the cable's integrity in wet environments. Proper cable support is essential to prevent the cable from sagging or rubbing against other objects. The cable should be supported at regular intervals using cable trays, hangers, or other appropriate supports. Proper cable bending is also important to prevent damage to the cable's insulation and conductors. The cable should be bent gradually to avoid sharp bends that could weaken the cable. Proper cable termination is essential to prevent water from entering the cable at the ends. The cable ends should be sealed using heat shrink tubing, epoxy-filled connectors, or other appropriate sealing methods. Regular inspections should be conducted to check for any signs of deterioration or damage. Any damaged sections should be repaired or replaced promptly to prevent further deterioration. In addition to the technical aspects, it's also important to consider the environmental impact of the cable installation. The cable should be installed in a manner that minimizes disturbance to the surrounding environment. This may include using trenchless installation methods or restoring the site to its original condition after the installation is complete. In conclusion, the BS600 Volt IMSA 20-1 cable is a reliable and durable choice for wet environments due to its robust construction, water-blocking features, and fault current protection. Proper installation and maintenance practices are essential for ensuring the cable's long-term performance and minimizing its environmental impact. These cables must also adhere to regulations of NEC, where cables are constructed to withstand the conditions for underground and wet environments.